A random variable is a set of whatever you want it to represent. Once again, a random variable is nothing but a set of whatever you want it to represent. A random variable can represent, for example, the alphabet X can represent all the possible even set of values when you throw a dice, or it can represent all the odd set of. So X, as you are seeing, that is a random variable, usually represents a subset within the entire sample space. The entire sample space, when you throw a dice, are the numbers from 1 to 6, 1, 2, 3, 4, 5, 6, and the random variable is a subset within the entire set, the possibility of even or odd values, for example. You see, now it's completely up to you what the subset has to be. If you want X to be the alphabet to represent all the possible set of even values, so be it. If you want another alphabet, Y, to represent all the set of odd values when you throw a dice, so be it. It is completely up to you what you want these random variables X and Y to represent it. The full video on random variables is on Patreon. In this video you will be seeing the difference between a continuous random variable and a discrete random variable. Examples of continuous random variable, for example, the noise amplitude that is recorded, let's say when we are singing, it can be a number like 2.1, 2.2, so on. That is the example of a continuous random variable. Another example of a continuous random variable is water that falls into a bucket to measure annual rainfall, so on. Then the example of discrete random variables is given as the number of workers on a certain given day. The full video for this on Patreon includes more examples on discrete and continuous random variables, and more examples of random variables as subsets, usually, of sample space, and also its possible applications into the field of quantum physics. In the description of this channel there is a link to an ebook that I have composed, which deals with all the building blocks of math into just one ebook. Imagine complex numbers explained to you with the help of animations as shown on the leftmost corner of this image, of this animated image, that I raised to 1 of complex numbers is rotation by 90 degree in the anti-clockwise direction. I raised to 2 is rotation by 180 degree. I raised to 3 is rotation by 270 degrees, and I raised to 4 equals to a full rotations by 360 degree. In fact, I raised to 8, I raised to 16, I raised to 12, I raised to any multiple of 4 will be full complete rotations, and that's why it comes back to 1. What if this ebook explains to you cos theta as a measure of how much parallel or how much aligned two forces, objects or influences are? What you can see in this image, what is shown to you in the rightmost and topmost corner, the more the sphere-like object is parallel to the surface of the table, the more the shadow, and at 90 degree when it is the least aligned with the surface of the table, the lesser the shadow. Complex numbers can be visualized as shown in the Mona Lisa image as vertically opposite mirror images of each other. So 3 plus 4i and 3 minus 4i are vertically opposite mirror images of each other. 3 plus 4i denotes tilted at a certain angle, and 3 minus 4i also denotes tilted at another angle. Transpose of a matrix is nothing but the entire matrix rotated by 180 degree. Sine theta is a measure of how much perpendicular two forces or objects or influences are with each other, as you can see in the animated image. The link to all the three ebooks is mentioned in the description section. There are three ebooks: Visualizing Math 1, Visualizing Math 2, and Quantum Leaps. Visualizing Math 1 deals with concepts like complex conjugates, trigonometry, integration, differentiation, and complex numbers in an intuitive fashion with down-to-earth examples and analogies. Visualizing Math 2, on the other hand, deals with concepts like Fourier transforms, which is nothing but the entire wave rotated in a horizontal plane by 90 degrees. That's what e raised to minus j theta means. E raised to j theta means rotation in a horizontal plane, just as e raised to I theta means rotation in a vertical plane. And after the wave is rotated, it has to be arranged in ascending order of increasing frequencies, just as children are arranged as if children are arranged as per their height in an ascending order. That's what Fourier transform. Laplace transforms means the entire wave tilted by a certain angle but not 90 degree in a horizontal plane and looking at a tilted angle. So it is Laplace transforms looking at the wave by rotating it in a horizontal plane in an angle less than 90 degree. And such other examples. It also deals with Hermitian matrices. Visualizing Math 2. Visualizing Math 2 also deals with a number of other theories like Hooke's law and so on.